All right, this video is on topic 3, lesson 3, activity 4 and 5. And then we'll get to the assignment at the end. So the title is solving equations with efficiency. So with this, we're going to have somewhat of a complex equation. As you can see here, we have an equation with multiple fractions, right? For me, I don't like to deal with fractions, so how can we get rid of those fractions? So with this, if you look right here, it says the LCD of the fractions is 6. The LCD is the least common denominator. So what it means is, as you can see in our denominators of our fractions, we have 3, 6, and 3. If you list out multiples of that, so what I mean by this is like multiples of 3 are 3, 6, 9, 12. And for 6, right, that is 6, 12, 18, and so on. The one that's the least common multiple, or the least common denominator, the one that they both share, is 6. What you can do in this equation is multiply everything by 6, as you can see here and here. Right, when we multiply by 6, right, this becomes 2 because 6 divided by 3 is 2. This becomes 10 because 6 divided by 3 is 2. But if I multiply that by this 5 there, that becomes a 10. We're going to work on problems like this, but for the first one, explain how the new equation resulted from multiplying both sides of the equation by 6. So with this, we got this 2 here, right? The 2 was because we did the 6 times the 1/3. That's from this part. The next part is the 5, 6. This 5, 6 became 5. The reason is because 6 times 5, 6. Right? If you take that, divide it, it's 1. And 1 times 5 is just 5. And then the last part we talked about, it became 10x. We're just going to talk about 10. It's because 6 times 5/3. Right? 6 divided by 3 is 2. And 2 times 5 is 10. So, right, that hopefully not too bad for this equation. So what is the solution to the equation? Well, we can take this last part here and solve it. So 14x plus 14, let's write that. 14x plus 14 plus 5 equal to 10x. We can move our variables to any side. I'm going to move our variables to the right side. I'm going to subtract 4x. This is 6x. Let me combine these two things. They're constants. 14 plus 5 is 19. And if we divide both sides by 6, our final answer is actually just an improper fraction. It's 19/6 equal to x. Final answer, we can convert this to a mixed number or divide into a decimal, but that is the correct answer there. All right, let's turn this over to the back side, or next page. We're going to skip a couple problems, but we're going to start with number 4 here. Solve each equation by multiplying both sides of the equation by the LCD, the least common denominator. So let's look at this. We have a 4 in a denominator. We have a 2 in a denominator. So list out the multiples of 4. 4, 8, 12. Multiples of 2. 2, 4, 6, 8. And we find the smallest one that they both share. They both share a 4. So what we're going to do here is we're going to multiply everything by 4. So how does that look like? What does that equation become? I'm going to multiply this part by 4, this part by 4, and this part by 4. Let's see what it becomes. Nothing ever touches the parentheses here because that's like a force field there, so nothing happens with that. But 4 divided by 4 is 1, and 1 times 1 is just 1. So really it's just 1 times x minus 5, which is just x minus 5. I guess I could put a 1 right there. Next one, 4 times 9 is just 36. And finally, a half. Half of 4 is a 2x. So notice how just by multiplying that, we got rid of our fractions here. And we're just left with this, I think, easier equation. I'm going to drop the parentheses since there's nothing happening with it. And let's solve it. So I'm going to subtract x to both sides. 2x plus 1, or sorry, 2x minus 1x is just 1x or x. And negative 5 plus 36 is 31, since they're different signs. And we're done. X is equal to 31. Final answer. All right, sounds good. Now let's get to some practice on the next activity. We're going to skip all these parts. Practice solving linear equations. We're going to do 2 problems on this side, a problem on the back side. Call it a day. That's the notes. Hopefully these notes are a lot shorter than the last one. So for number 2, find the least common denominator. The least common denominator here is going to be 4. We just did that in the last problem because we have a denominator here of 2, a denominator here of 4. Let's multiply everything by 4. So what happens here, we'll multiply that by 4, this by 4, every expression by 4. Now this first part, 4 divided by 2, I'm going to cross this off, is 2. There's still a 2 in front of it, and let me just write what it becomes. All right, so for that, I'm still going to put, we're done with the fraction, but it's 2 times x, 10x plus 2. We'll get to that in a little bit. Here, right, 4 times 4x, there is no fraction, so I just multiply it. It's 16x. And here, 1/4 of 4, what's 4 divided by 4? It's 1. And then 1 times 1 is just 1, so plus 1. Let's use our distributive property. So 2 times 10x is 20x. 2 times 2 is 4. We still have the 16x. We have the plus 1. You get to choose where you want to move your variables to. I'm going to move my variables to the left. So variables to the left here, minus 16x, so that all my x's are on the left. 20x minus 16x is 4x. I'll just put 1 there, but it's plus 1. Okay. And then from there, we'll subtract 4 to both sides. We have 4x equal to negative 3. If we divide both sides by 4, that's our final answer, negative 3/4. I'll put the negative kind of like in front, in between the 3 and the 4. So negative 3/4, that's our final answer. So although we got rid of the fraction, we did have a fraction as our final answer, but we didn't have to deal with any fractions as we were solving. All right, and let's go to number 3. So what is the least common multiple of 8, of 2, of 4? I'm just looking at only the denominators here. So let me start with 8. We got 8, 16, 24. And we already know that the least common multiples of these two is 4. So let's do a multiple of 4 then. So 4, 8, 12, 16, so on. The smallest one that they both share is an 8. So let's multiply everything by 8. I'm just going to multiply 8 times this, this, and this. Right? It doesn't at all go into the parentheses. It's a force field. So like that, and like this. So here, I always do work with my denominator here. 8 divided by 8, that is 1. What's 1 times 3? It's a 3. So this is going to be 3 times x plus 8. Fraction is gone. Great. Here, it says 4, or, well, I mean, we can use a half. What's half of 8? 4. So I'll keep the 4, I'll put the 4, and I'll keep this x plus 5. And here, what's 1/4 of 8? Maybe we don't know that, but we can divide it. What is 8 divided by 4? It's 2. What's 1 times 2? It's a 2. So this is just plus 2. So final answer here for this, we're going to multiply and use the distributive property. So 3 times x is 3x. And then 3 times 8 is 24. And then we're going to have to use the distributive property again. 4 times x is 4x. And 4 times 5 is 20. And then we just keep this plus 2. So, right, still a complex equation, but let's move our variables to the left side. I'll subtract, well, actually, no, let's move it to the right side. I'll subtract the 3x here. So that equals 0. We'll keep the 24. 4 minus 3 is 1x, or just x. You know, I'm going to add these two. 20 plus 2 is 22. And we'll subtract 22 to both sides. 24 minus 22 is 2. We get 2 equal to x. So final answer, simple enough. 2 equal to x, or x equal to 2. Same exact thing there. All right, and we have these other problems that you're more than welcome to do as you-dos. But let's turn over to the next side. We'll do number 11, and that's it. Okay, so let's use the distributive property here. Let's use the distributive property here. There's no fraction, so don't have to worry about the least common denominator. Okay. So let's put 3 times x is 3x. 3 times negative 1 is negative 3. Nothing happened with this x. This will be 4x plus 8. 4 times 2 is 8. Let's combine some things. I'm going to combine these two things. That's a 1. 3x plus 1x is 4x. Let's move our variables again to the left side. I'll subtract 4x here, subtract 4x here. That equals 0. But this also equals 0. So variables canceled. Whoops. But we have this statement here. Negative 3 equal to positive 8. That is a false statement. So there is no answer here. And when we have a false statement, what is the solution? It means it is no solution. Right? If we had negative 3 equal to negative 3, that's a true statement. That would be infinitely many solutions. But since it's false, no solution. Okay, good. I'll give you some time to copy that down. But we're skipping this page. Our assignment, same assignment from yesterday, but some classes got to, some classes didn't. Number 1, you get to choose which one you want to do, A, B, or C. Number 2, A, B, and D. And number 3, just C and D. And we're done with that. Turn it in, and then get to Matthew. Okay, let me know if you have any questions.